Let's use the substitution method to solve the system of equations 1/4 x minus 2y equals 1 and x minus 8y equals 4. When we use the substitution method, we start by looking for the lone variable. Here it is, x. So I'm going to solve this bottom equation for x. We do that by adding 8y to both sides. That gives us x equals 4 plus 8y. Okay, and then I'm going to substitute that in to the other equation right up here. I'm substituting that x in for this x, and I'm careful to put parentheses around this because this 1/4 gets multiplied to all of x, but x is 4 plus 8y. So I'm going to include those parentheses. So this top equation now becomes 1/4 times the quantity 4 plus 8y. Alright, and then minus 2y equals 1. And look what we have now. We have a single equation that we can write in terms of just y. We can solve in terms of y, which is great. So let's distribute the 1/4 through to these. Alright, so that gives us 1 plus 2y minus 2y equals 1, and something is strange here. Look at this. 2y and 2y. Plus 2y minus 2y cancel out. We get 1 equals 1. And this is true no matter what we put in for x or y. So I'll say true regardless of x or y. It doesn't care what x or y are. This is vacuously true, right? 1 equals 1. This doesn't even care what x and y are. So what this means, when you get a solution like this, we could have solved this a different way and gotten 0 equals 0. When you get a solution like 1 equals 1 or 0 equals 0, that means that graphically these two lines that we started with are actually the same line. Okay, so really they're the same line. Remember that a solution to a system of equations is where the two lines cross. But when the two lines are the same line, they cross everywhere. So we'd say that there's an infinite number of solutions. We don't say all real numbers, though. Infinite number of solutions. Right? We're graphing one line on top of each other, and then we're asking, where do these lines cross? Well, they cross at an infinite number of points, but they don't cross everywhere on the plane. So we don't want to say all real numbers or something like that. We say an infinite number of solutions, but more mathematically, write it in a very specific way. And what we want to say is the solution set is x and y such that they lie on these lines. So this bar right here means such that, and then we say, okay, such that 1/4 x minus 2y equals 1. I just put in the equation of the first line. So what this says is all values of x and y such that x and y lie on this line. And this would be an answer, how you would write an answer to this system of equations. An equally good answer would be the set x and y such that x minus 8y equals 4. Because that's the other line, and we already know that these are the same line by solving and getting this solution here. Anytime we get 5 equals 5, or 10 equals 10, or 1 equals 1, 0 equals 0, that tells us that our two lines are actually the same line. So it doesn't matter which version of the line you write as your answer, it's going to be correct. So pick one of the two. You wouldn't want to write both of those for your answer, and just go with it. And just as a note, if we go up here, let's clean this up a little bit. You can see that these are the same line right up top by multiplying this top one by 4. If we multiply this top row by 4 here, we get x minus 8y equals 4. And now we can see that they're identical lines. By multiplying by 4, I mean multiply both sides by 4. Both sides of that equality. So indeed, they really are the same line.